Hello everyone. In this session, we will discuss about the maximum torque of the three-phase induction motor. In the last session, we discussed about the approximate torque equation and the observation on the approximate torque equation. In this session, we will discuss about the maximum torque. First, we will define what is the maximum torque. The definition is, this is the highest value of the torque. This is the highest value of the torque developed by the motor for given machine design. So up to this, the motor will give the maximum torque. Up to this point, the motor will give, yes. Or this is the torque developed by the motor which moves from motor stable state to unstable state. So we have the induction motor is there. So we have the torque. Yeah. So at particular torque, this is stable state. But when the torque, if torque increases, at which torque after the torque, the induction motor will become, the stable induction motor will become the unstable. So that's why this is the torque at which induction motor become into the unstable state, stable state to unstable state. Okay, yes. So to get this, first we will write down the first torque equation. The torque equation value is like this, that is, here the torque equal to K S E2 naught square R2 by R2 square plus S x2 naught square. This is the general torque equation. You know the K value 180 by 2 pi ns. This is the constant. Always you make it as a constant. Okay. Here the condition for the maximum torque can be obtained by differentiating the torque with respect to the slip. So the condition for maximum torque can be obtained by differentiating this equation, differentiating torque with respect to S and equating to 0 that means d torque by ds is equal to 0. So by doing this differentiation, we will get one condition. That condition is R2 equal to S x2 naught. R2 equal to S x2 naught. This is the condition. That is, the rotor resistance will be equal to the slip times of the rotor reactance at standstill condition. That means rotor resistance will be equal to the slip times of standstill condition. So from this is the condition for the maximum torque. So we can find out the slip at maximum torque. The slip at maximum torque value will be R2 by x2 naught. The value will be R2 by x2 naught. Here the rotor resistance, x2 naught is the rotor reactance at the standstill. So here the torque developed by the motor will be maximum, where slip at torque maximum, the slip corresponding to the maximum torque. Here we can write, you know, the rotor resistance and the rotor reactance. This is, what is this value? Slip at maximum torque. Slip at the maximum torque. Okay. So by using this slip at maximum torque, we can find out the speed. The induction motor speed. The induction motor speed is the rotor speed at torque maximum equal the synchronous speed into 1 minus slip at the torque maximum. So just replacing slip with the slip torque maximum, then we will get speed at the torque maximum simply. Okay, just so the finally the torque will become maximum torque, where you should substitute resistance R2 with S x2 naught, S x2 naught. So here you know the torque value K S E2 naught square into R2 by R2 square plus S x2 naught square. This is the general thing, and we should convert into the maximum torque. Just you replace this wherever the R2 is there, just replace R2 with S x2, then it will become Ks and E2 square. R2 will be S x2 naught by R2 is S x2 naught square plus this is S x2 naught square. So by doing the calculation we will get K slip is 2 times, so slip square, only one E2 naught square is there. What about x2? We have one x2 naught by we have with terms is 2, that's why this is the 2 times of we can write slip square plus x2 naught square. So both slip square will be cancelled and x2 naught will become 1 x2 naught. The finally the torque we can write like this. The maximum torque equation value is like this. The maximum torque is K E2 naught square by 2 times of x2 naught. 2 times of x2 naught. So this is the maximum torque equation. This is the maximum torque equation of three-phase induction motor. So this is the direct equation of the maximum torque. The torque at which maximum developed by the induction motor is, this is the formula, that is K E2 square by 2 into x2 naught. 2 into x2 naught. So we can get this maximum torque in the another method. So that method is a maximum power transfer theorem, but we don't need this. Just we will have some observations. So before the observation, once again we look at the maximum torque. So maximum torque means the maximum torque developed by the induction motor. What is the meaning of the maximum torque? Means here the stable induction motor will become into unstable state. So our intention is to always any motor or any machine should be in stable mode. So how we will get? By doing the torque maximum value, the variable thing is slip only here. So that's why we are taking the slip, differentiating the torque with respect to slip and equate to 0 when we will get the condition. That condition equal R2 equal S x2 naught. So just substituting in the torque will become the maximum torque. Torque will become the maximum torque. By doing the calculation, we will get 2x2 naught. Okay, 2x2 naught. So we should have again some observations. We should have some observations here. So this should be useful to understanding the maximum torque. So now we will make some observation on the maximum torque. Here the first observation is, so before the first observation, first again this is the torque maximum, right? The first observation is, if all drops are neglected, the first observation, if all drops are neglected, whenever the all drops are neglected, then what happen? The stator EMF and rotor EMF all will be same, that is E1 equaled E2 naught equaled will be V. Then what is the relation? The maximum torque maximum torque is proportional to the voltage square. Look at here, this is the voltage square. So by just observing this, the input, if the input voltage is increased by 10%, if the input voltage is increased by 10%, the maximum torque will be increased by 20%. So same as that of the normal torque. Maximum torque and the torque will be both are same. If the input voltage increased by 10%, then maximum torque also increased by the 20%. Okay, this is about the first observation. Okay, and we have the remaining observation. That remaining observation will be discussed in the next session. Okay, this is about the maximum torque equation. I hope all of you understand this session. Thank you.